Hello everyone, welcome to one more important video, and today we will discuss about the Gaussian integral. Gaussian integral has very wide applications in probability, statistics, and some other higher mathematics or the engineering mathematics, and even in the engineering subjects. But first of all, it is important that how to integrate it, right? So it is not a normal integration that you can do by substitution method or by some other method. We have to do some adjustments so that we can get the answer of this integration, right? So it is famously known as a Gaussian integration. So it is known as Gaussian integral, right? So Gaussian integration is something about that helps in, as I told you, in various engineering applications, right, or even the real life applications also. And it is very important for the statisticians, right? Those who are just dealing in the data, right? Okay, so let assume this integration as I. So this is minus infinity to infinity, and this is minus e power minus x square dx, right? So first of all, I'll be using some adjustments. Like as I told you, it is not a normal integration, so I cannot do this integration just by taking one variable. I have to do some adjustment in the higher mathematics, right? So first of all, I'm going to square. If I square it, so it means that I have to multiply this by 2 times. I have to multiply this by 2 times. Okay. So once I multiply, I can change the variable also, right? So I'm going to change the variable of one of the integrals, e power minus x square dx, and for that I can, because this is a real coordinates x and y, real coordinates means I can assume this as a space. So minus infinity to again plus infinity, and this is e power minus y square dy, right? So I have replaced x by y. So again, if I just add them, because we have the same basis, and it is a double integration now. So it is double integral e power minus x square plus y square and dx dy. Now by looking at this expression, definitely you are very sure that this is going to form a circle. This is going to form a circle, right? So it can be the circle. If I equated something like radius, so it can be a circle equation, right? So what I can do, I'll replace, I'll go in polar coordinates. So in polar coordinates, if I say x equals to r cos theta and y equals to r sin theta, right? So if I make a circle, of radius r, this angle is theta. So this x length is r cos theta, x equals to r cos theta, and this y is r sin theta, right? So in polar coordinate, I can convert x as r cos theta, that is r the radius, and theta is the orientation or the inclination, right? This is theta. Okay, so I got it, and if I square them, x square plus y square, add them, square and add them, so I'll get r square cos square theta plus sin square theta. So this is going to be 1, so I can say x square plus y square is r square. I believe it is clear. I believe it is clear, right? So what I am going to do, I'm going to replace it, right? But once I replace x and y in the polar coordinates, the limit has to be changed, right? Limit has to be changed. So just try to think what can be the limit for the theta. So theta can only vary from 0 to 360 degree. Theta can only vary from 0 to 360 degree. We cannot take theta something different. And r can take any value. R can take any value because 0 to infinity. R cannot be negative, but r can be very large radius. So I have to change the I have to change the limits also, right? So for the angle time, it is 0 to 2 pi angle d theta, and 0 to infinity for e की power, I can replace x square plus y square is r square dr. Okay, but one more important thing you must understand is that how to find dx dy, right? So what is the value of dx dy, right? So you have to understand by the point of time dx dy is r d theta. So as of now, you can remember it. But if we want to prove, we have to use some Jacobian method or some visualization method. But you can understand this is area. This is area, just a very tiny piece of dx dy. So once I convert them in the polar coordinates, this area will be something like that. So outer portion will be more and inner portion will be less. That's why. So this is r, then this has to be r d theta. That's why its area is be r d theta. That's why, right? So this is something different. So in further lecture, I am going to explain this also, that why this dx dy equals to r dr d theta. So by the time you can understand this d theta is as it is, and this can be written as r d theta, right? R dr, right? Now I'm in a position of just calculating the values now, right? So I'm going to erase it. I'm going to erase it so that I can solve the integral. Now this is something I square equals to. So what is the, now these are independent, huh? These are two different integrations, so we are not bothered about the replacement, just we can do them independent. So what is the integration of this? Something like x dx. So dx will be something x, right? So it is only theta, and limit is 0 to 2 pi. Now I can replace, right? So if I take like 0 to infinity e power minus r square r d r. So I'm going to take r square is something like a minus r square is something like we can take t. We can take t. Okay. So this is minus 2r dr is dt. So I can replace r dr. I can replace. So this is going to be 2 pi multiply by. So this is minus r dr is dt upon 2. So minus 1 by 2 minus 1 by 2 integration is 0 to infinity, right? So if you put r0, then t will be 0. If you put r infinity, t will be in infinity. Limits remains unchanged. So this is going to be e power t, and this is r dr is dt. So everyone knows, huh? Everyone knows that this is going to be the same integration, right? So I square is nothing but 2 pi. Okay, so this is going to be minus 1 by 2 e power t, and this is going to be 0 to infinity. This is going to be 0 to infinity, right? This is going to be 0 to infinity, right? 0 to infinity. Okay, so I square is nothing but, now this is remaining 2 pi, or we can cancel this also. So this is pi, negative pi. Now if I put e power infinity, and this is e power 0, right? Or I think you could be very confused that if I take e power infinity, that is a very big number. So for that adjustment, what I can do, I can remove this r square simply as t also, right? So this is simply 2r dr is dt, right? So I think this is easy, so that I can put it just half here, no negative, just half here, no negative. Okay, so just half, no negative, then this negative will be appearing here. This negative will be appearing here, right? So this is going to be e power minus t, right? So e power minus t. So what is the integration of this now? So this is pi into negative of e power minus infinity minus e power minus 0, right? I believe it is clear, right? So this is going to be I square equals to pi. So this is negative of 1 by infinity. Huh? So if you take 1 upon infinity is a very big number. So 1 upon infinity is a very big number, right? So I can take it 0. If I divide 1 by any big number, so it is approaching to 0, right? And this is 1 upon 0, e power 0. So this is going to be 0 approaching to 0, and this is going to be 1. And negative will make it positive, right? Negative will make it positive. So I square is pi. So I is nothing but root pi. So the value of this I is root pi. So this is very interesting result, that how this pi appears. But this is very important, and once you just go into the world of probability or statistics, you find this that this is the normal bell curve. So this normal bell curve include 100% data, whatever be the data that we are dealing the real life. This is normal bell curve. Okay, so I hope you understood that how we got the value of root pi. And if you have any doubt, if you want to have any suggestion, then you can throw your comments in the comment box. And for more such videos, you can start following me. And see you in the next video. Bye. Take care.